is a function. And again, our reasoning is x values do not repeat. And when I say x values, again, remember I'm talking about that input or domain. Remember those synonyms we talked about. Okay, so another way to determine if a relation is a function is to do the vertical line test. I know that they talked about this in the video too. This ultimately becomes people's favorite way to determine if something is a function or not. Okay, so I'm just going to draw a couple of examples here. So we're going to make a quick graph. Super easy, low key. Right? Nothing fancy. Okay. And then I'm just going to put some points on this graph. Okay. So when you look at those ordered pairs, what we're trying to determine is if it would fail or pass the vertical line test. If it fails the vertical line test, that means it's not a function. If it passes the vertical line test, that means it is a function. Okay, so let me get my colored pencils out here to show you what I'm looking at. I'm going to get red out because, you know, red is danger, right? Okay, so what I'm looking for is if I draw a vertical line anywhere on this graph, does it go through more than one point? If I draw a vertical line here, so I'm just going to highlight this in red, do you see how it goes through these 2 points? That is an indicator that my x value repeats. Okay, so this is failing the test. Womp womp, right? So since it fails the test, not a function. Okay, this disqualifies it, that it fails the test. Again, it doesn't matter that these y values are the same. It does not matter. Now, and some of you might be thinking, x is y's, what do you mean? Okay, so if I were to make these as ordered pairs, like if I were to list these as ordered pairs, I would get 1, 2, 2, 1, 2, 2, and 3, 2. Right? So if I were to write this out as a list of ordered pairs for my relation, now I can see that these x values of 2 repeat, and that's what's being shown here with this red line. Okay. Again, I have these y values, 2, 2, and 2, doesn't matter. It's the x values of 2 that repeat that make it, that determine whether or not it's a function. So let's do another example similar to this. Let's go ahead and draw a beautiful graph. We've got our x-axis and our y-axis. Okay, so I'm going to just put some points on here. Right. So when I look at this graph and I ask myself, does it pass the vertical line test? Well, if I draw a vertical line anywhere on this, does it go through more than one point? Nope, this passes. So this passes the vertical line test. This is a function. Okay, pretty easy, right? And then this last one more graph. You guys are doing a great job. I'm not even going to put numbers, I'm just going to draw a squiggle. Okay. Now, if I were to take my red pencil and draw red lines vertically anywhere on this, is it going to pass through that line more than once? It won't. It might look like it, but because it's curved and we don't see any vertical parts of this function, that means it passes the test. This is a function. Pretty exciting stuff. All right, we're almost done. Now what I need you guys to do is go up to the counter, and I need you to grab 4 of these graphs. Okay, so there should be a big stack of them on the counter. I just realized I need 2 more, so let me go grab a couple more for myself. So I went ahead and cut these out for you guys so we can, and this way you don't have to draw the graphs for this next section. Okay, so that was page 10, right? Now I'm going to go on to page 11, and this is where it gets real fun. This is when we identify domain and range. Okay, so remember, domain and range are those synonyms for x values and y values. So we're going to be looking at different graphs and deciding what the domain and range are for those graphs of those functions. So we'll get into some examples. The first example is just a relation that's a set of ordered pairs. I got those fancy brackets. Okay, so my domain is going to be -1, 2, and 5 because those are all my x values. And my range is going to be 4, 3, and 6 because those are all of my y values. Okay, pretty straightforward. What are my x's? What are my y's? All right, so for this next example, we're going to glue in our graph. Okay, so remember I've got the y here is the vertical, the x is the horizontal. Okay, and then I'm just going to put some points here. Okay, so go ahead and plot those points on your graph, right? And I want you to identify the domain and range. So it might seem a little hectic right now because all it is a bunch of points on a graph. But the way we're going to do this is we're going to make ordered pairs for each of these points underneath the graph. And then you'll have a perfect list of your x's and y's. The reason I encourage you to do that is because otherwise, if you just try to write out the domain and the range real quick, you might forget a point, you might duplicate a point, but this way we have a organized way. So what I do is I go from left to right, the points on the graph. Okay, so I'm just going to start listing each of these ordered pairs, right? So I've got my relation symbol. I've got ordered pair -5, 1. I've got -3, -1. I've got -2, 4, 0, 0. Sometimes that gets forgotten, the little origin one.